Hello. Hello, testing. Assalamualaikum. Can you hear me?
Ada.
Boleh. Okay. Sorry about. I have a technical problem. I cannot connect using my laptop. So can you hear me loudly using from my handphone? Is it clear?
Boleh.
Yes, doctor.
Okay. Alright. Okay. So okay. Let me just open the. Okay. As usual, please go to the you learn. Okay, you learn and then open and take the attendance for this morning. Okay. Okay, you should be able to see the screen right now. Okay, so what you need to do is like go to ULearn and then go to week. We are now in week 12. A bit delay since last week we postponed the class due to banjir, the flood. So week 12 is 13 January, and then next week will be week 13. Week 14 will be 3 days only. So week 12 is that for today is that we are going to discuss a bit about the assignment, and then tomorrow will be on the last chapter, which is on basic control system. So please take the attendance. And FYI for the reflection here, I have not updated the link to this feedback, so might be a bit late for today. So maybe after 12 noon. Okay, so let me just open assignment. Okay, there are three students that submitted to me assignments via the email. As mentioned, I'm going to discuss about the assignment. So those students who submitted, I will discuss their answer. If their answer is appropriate with to the case study given. So basically, okay, but FYI, for today discussion is that since the student who submitted to me, I'm going to show their solution. So bear in mind, for the other student, do not copy lah the answer. So I take note on the student who submitted the assignment today to me, and I'm going to share it with you guys. So do not copy their answer. Okay, this is for discussion purpose. So you need to come up with your own solution. Okay. So just open the assignment. Okay. First one will be Chew, eh? Okay, Chew. Which case study number did you get, eh? Chew.
Case study E.
E, eh? Okay. Let me just open that. Okay. All right. Okay. So this is case study E, the question. So let's just go through the what are the case study about. So case study is about a marker pen a marker pen producing company wants to increase its productivity by automating the injection of ink into the marker filter as depicted in the following figure. Okay, marker filter is a method that stroke ink in marker pen. So basically, okay, imagine that this figure is shown here is manually done. So before we have the production line and everything about automation, production, mass production, and so on. Before this, so everything is done manually. Okay, manually means that a human will actually insert the ink, the needle into the filter and so on, blah, 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 and so on, and then come up with the pen, okay, in the production. And nowadays, they come up with the pen in mass production, mass production. Mass production means that more than 100,000 product in for example in 1 minute. Okay, so that company they want to actually automate the system. So what happens that they want to convert the manual production line into an automated production line. So this type of production is being done if you are taking later in year 4, which is advanced manufacturing system. Last time I was teaching this subject, so you will learn about how manual production line is being converted to automation. Okay, automated system. So how is the layout of the system and so on. Okay, so basically this figure shows how it should be done. So you need to have a plunger, spring, and then barrel. Barrel is where you are going to actually insert the ink into the marker filter. Okay, and so on. Okay, so the idea is that the problem is that to automate the injection of ink into marker filter. Okay, so the process has the following requirement specification. So using spring-loaded syringe that dispense ink when pressed and sucked in from the reservoir when released. So basically, this first sentence is is explaining about this part. Okay, so use loaded syringe. So this is a syringe lah basically. Okay, there's a spring, and where the ink will be dispensed into the marker filter. Okay, when from the reservoir when released. So reservoir is the barrel itself lah. Reservoir ni adalah is something that with whole liquid. Okay, reservoir. Macam dam lah. Dam, dia ada dalam tu ada liquid kan, ada water. Okay. Second one is an injection 50 ml of ink per filter. So basically, you are going to actually transfer 50 ml of ink every time, each time into the marker. Okay, so it should be 55 mm, it should be 5 mm lesser. So it need to be exactly at 50 mm. Okay, so basically you need to have a controller there. Okay, when we have this type of wording. The syringe plunger travel 50 mm to inject 50 ml of ink into the filter. So basically the plunger here, the spring here is going to travel 50 mm to inject. Means that is going to travel in linear motion. Okay, travel in linear motion. So this spring is going to travel from this point to this point. Okay, travel linearly 50 mm. So you can draw it on your own how it's going to travel. So list out from all of this um, based on the assignment. So what was the assignment about? Okay, so this was the case study. So let me just open the question of the assignment. Okay. Okay, so from the case study is that Of course, that what the case study is the problem given. So you have been given same 7 main stages. So which is you're going to refer to the references. Okay, stage one, what are requirements? So basically, the case study just now explain about what are the problem requirement needed. So you need a controller to control the 50 mm travel. Okay, motion. Then you want to control 50 ml dispensing of the ink. Okay, so list out all of the requirement needed by the customer or client. So those are the requirement. So analyze the problem. So based on that, you need to analyze, prepare, and generate your solution. Okay, so basically from stage 1 stage 7 is being defined into this task 1, 2, 3, and 4. Okay, and 5. So into 5 tasks. So what you need to do is that, as mentioned, you need to cover all of these element and measurement system. You need to have a sensor, and when you have your sensor, need to have a sensor collision and data presentation. And then you need to have actuation system. It's either electrical actuation plus mechanism, okay, or you want to choose pneumatic actuator plus mechanism, or hydraulic actuator plus mechanism. And of course, there are some students who actually contacted me. Okay, you can also choose, maybe you think that for your system, the case study, you need to have a 2 different actuator system. You want to have electrical actuator system plus mechanism and also the pneumatic actuator. Okay, so it depends on you. Okay, if you think that to solve that problem, you need these 2 actuators, then you need to define why. Eh? I'm not saying that if you list more, you get more marks, but if it's appropriate for the system, then yeah, you should list that out. And the control system. Okay, most of the case study you need to control something. Okay, you might need to control the displacement. You need to control um the 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 quantity of it. For example, 50 ml just now. Okay, so based on that, okay, what you need to do is that the first one is that list the function and description and flow and description. So basically, this function and description is going to be covering this number 2. Okay, but so I'm going to show Q answer is the case study number E. So bear in mind to other students who got this one, do not copy Chu's answer. If you copy, then I know you copy from Chu lah, basically, and then you get 0 mark. Okay, it shouldn't be exactly. You should think on your own. Okay, so let's look at Chu. Okay, so for Chu, he listed out. Let's see. Okay, he listed out 9 flow and function. So the first one is that, okay, my suggestion is that, okay, when you list out all of the flow and function is that, try to list out what based on the stages, okay, like the Chu just now, okay. So I have, okay, if you see in assignment, the first one is that stage 1 is design the process and the requirement for customer client. So based on this question, okay, go to the case study question. Okay, so what based on the above sentence, this sentence, first one, I already explained what was the problem just now. So you list out what are the problem. Okay, what are the requirement by the company. Okay, of course, this is also the requirement, the main requirement. So you can list out the requirement, main requirement. Okay, based on this requirement, you actually can list up. Okay, for the spring loaded syringe. Okay, do I need a sensor there? Okay, do I need an actuator there? Okay, do I need a controller there? So you list it out. Okay, also for inject of 50 ml of ink per liter. So do you need an actuator? Do you need a sensor? Or do you need a controller there? Okay, so list out all of the problem, and then after that, you can list out your solution. Okay, of course, like Chu, he lists out this function and description fluent, but I do not see what was um the requirement. Where is the requirement? So you can add another another column here before function description. Okay, requirement of the the requirement is what. Okay, so for example, converting energy into linear motion. Okay, that one is referring to the the strange plunger travel 50 mm. Okay, so that is requirement and specification. Sorry. Okay, so number one, I think the function is okay. Okay, convert the pneumatic input is air. Okay, and then a bit about explaining. So explaining here, of course, Chu explain, okay, and let the 50 mm disperse in blah blah blah. So I would suggest before this function description, add on the another column which is requirement. Okay, second one, detect the presence of ascent of the piston rod of pneumatic cylinder. Okay, so this one, maybe you want to have the sensor or the signal processing there. So signal, okay, give a signal. And then number three, control and regulate the overall system of programming. So this one, basically, I would say, receive the data from the sensor, but then okay, this might be on the controller part, because they want it will control the solenoid, two-way valve, and so on. Okay, change the direction of the airflow. Okay, means that extending and retracting. Okay, so I would suggest number three and four, it might be almost similar because it's talking about the pneumatic actuator there. So you might want to, if you give this answer to me, I will only give 1 marks only for either three or four. It's not going to be add-on marks. So if it's redundant, then you will get only 1 marks. Okay. Number five, amplify the output signal from sensor. Okay, this one is okay. So on the signal processing. Okay, convert rotary motion to linear. Motion to convey the marking. Um, I'm not sure about this. Mm, what does it mean, Chu? Convert rotary motion to linear motion
One is the electrical attractor for the conveyor.
or conveyor? Okay. So I think yeah, you need to have to move the conveyor. Mm. Oh, okay, to convey the marker filter. Okay. Okay, give an instant visual indication. Okay, this one will be on data presentation. Convert electrical energy into mechanical. Receive the electrical from Arduino and start to rotate. Start to rotate. Start to rotate what? What part will be rotating? Number 8. Two.
Because number six, I think is I write for the
Conveyor.
electrical attractor, and the eight
Mm.
is the belt drive system.
Oh. Okay, so I think if you want to talk about that, then you definitely want to have the requirement there. So requirement is that on to control the conveyor, example lah, in front. Okay, requirement to control conveyor, then you can explain this one. If not, it's not going to be clear lah. When you talk about number 8, I'm not sure you're talking about which part. Eh? So you need to be clear. Either way, you can actually write out convert electrical energy into mechanical energy. Uh, in a bracket conveyor system. Okay, so you might want to add that, so that it's clear. Imagine you are the one who are marking the assignment, so I need to know this one indicating which part. Okay, so you need to add the requirement in front or somewhere inside here to mention that it's actually referring to a conveyor. Number 9, detect position of piston of pneumatic cylinder. Give the signal when detect the magnetic field of a magnetic integrated into cylinder piston. This one is referring to which one? Which part?
This
9.
case study are using two sensor. First is the
Mm-hmm.
magnetic sensor and second is
Mm-hmm.
the photoelectric sensor. For the
Mm-hmm.
photoelectric sensor is using for detecting the marker filter when conveying. So the conveyor will stop. And for this
Mm-hmm.
magnetic sensor is for detecting the position of the piston on inside the cylinder, pneumatic cylinder
Pneumatic cylinder is
for
for
extracting
pushing
and
the
yeah.
okay, yeah, yeah, of course, for extending and retracting, but for what? For pushing the pen or
Yes,
what? What does it do?
for pushing the plunger the
The plunger.
yeah.
So if you want to talk about it controlling something, what item is control? The plunger, the pushing the pen out of the conveyor. Because if I were marking your assignment, I might be thinking, oh, you want to push the pen into the out of the conveyor, example. Okay, I'm not sure you are talking about the whole general process or only on the plunger itself. Okay, because you already talk about the pneumatic cylinder up here. Okay, number 1. Okay, do you understand what I mean? So if I were looking at this, number number 4. Okay, number 4, change of control direction means that retracting and extending. And number 9 is almost similar. Eh? It looks different, but it's almost similar. It's talking about controlling the pneumatic cylinder, extending and retracting. So you might want to be more specific when you explain it, which part of it. Don't be too general like this. Okay, mention it which part that you are talking about. Okay, so that one is my comment on the first part. Okay, the task 2 is the organized structure. Okay, so basically you're going to start from the first part. Okay, human energy, push start button, control regulate. Uh, Task 2, task 2, organized structure, reject individual. Okay, if I were to give marks on this one, I would assume that this block looks like an open loop, open loop block diagram. So which means that it's not a closed loop. Okay, in the case study is that you should be drawing a closed loop block diagram, which is basically like this. So it's gonna be having the controller in front of here. Okay, the actuator part here. So you need to rearrange everything so that what what are the input that you are controlled will be in front here. Output is something that you're going to control. Then I will know when I look at the block diagram. And the front here is something that you're going to control. The output here, over here will be something that you're going to make sure that output and input is almost the same. Means the error you get it 0. And then under here is that you have the sensor. Okay, so I'm not saying that this is wrong, but it looks like I'm not sure which one is the starting point. Of course, this one, but I do not see which part is the end point, the output point. Okay, so I would say that the ending, they are two output here, which is this one, pneumatic actuator, and the marker filler moving towards fringe. Okay, so based on this, there's no closed loop. Okay, so you need to try to make it into a closed loop. Okay, not something like this. This is looks like the open loop. Okay, so magnetic field position signal. This one is an input, right? Input reference, so it should be at the point like this, like push button energy. So rearrange it. You can rearrange it like this, okay? And you can actually put it into dotted line and then label it as a controller architecture over here, uh, actuator here, and sensor over here. Okay, so you need to just rearrange it. Okay, Joe? Okay, number 3. Okay, based on the task number 1, okay, so what are the functions? So option 1, 2, 3. So okay, let me see. So you're going to convert linear to convert engine into linear. So your option is pneumatic actuator, hydraulic, and electric actuator. So you explain that why using pneumatic. Okay, okay, this is looks okay. Detect presence of absence of piston rod. Okay, there are 3 type of sensor that you suggest. So which one? So you say that for the electrical, why, and so on. Okay. Change of control. So you either want to use 5 to 2-way directional valve, control valve by pedal, by push button. Airflow. Airflow and from the change. This is if you give this option 1, 2, 3, I won't give you full marks lah. Okay. You know that you have 5 to 2-way direction valve, 5 to 3-way valve. So you should be using different type of category, not the same width by pedal, by cylinder valve, and so on. So you try to use different. Don't duplicate the same thing like this. If you duplicate the same thing like this, then you won't get marks here because it's almost the same. Okay, so let's say that you are going to develop this, and then you find out that there are different type of control valve, 5 to 2, 5 to 3, and so on. So based on that, you suggest that 5 to 2 why, and you have learned 5 to 2 why in class compared to 5 to 3, and so on. Okay, so you list out that one, but not by differentiated by solenoid valve, by pedal, by push button. Okay, this one is not the correct way. Okay, you won't get marks if you do this. Okay, number 5, amplify the output signal from the sensor. Okay, okay, this one is okay, inverting linear and so on. Convert rotary motion to linear motion. I'm not saying this is okay. I'm saying that you list out the different type of category of sensor. It's okay. Yeah. Convert rotary motion to linear, bed drive, chain drive. Oh, okay. Bed drive, chain drive, bed drive, flat belt. Conveyor marker. Okay lah, boleh lah. So because bed drive you have the tooth belt and flat belt again. So you choose tooth belt. Okay. Convert electrical to energy into electrical. So you use this one. Detect the motion, piston, magnetic sensor. Okay, this one is okay. Okay, so task 3 is almost everything is good except for a few list of options lah. Okay, task 4. Okay, sketch concept of design by including all component. Okay, this one is important. Whatever that you explain in task 1, 2, 3, the keyword should be inside here. For example, if you talk about stepper motor, this one number 8, stepper motor is selected. So I'm going to search in your diagram over here, where is the stepper motor? And I would suggest, okay, since you have left stepper motor for the part here number 8, okay, so you put their numbering 8, which is 8 stepper motor, because it's very hard for me to find it. Okay, so it's here, stepper motor. So right there, 8 in circle lah. Okay, so it's easy for me to look at. And I'm going to check if the location of the motor is correct to where you are going to link any mechanism. Okay, so as I mentioned, so you're going to use any type of actuator, it must be briefed together with a mechanism. So like stepper motor here, the aim is what? To move. What is the aim, Chu, of the stepper motor?
The conveyor.
Conveyor. Okay, to move the conveyor. So I cannot see the belting system that you choose. You choose the belt drive tooth belt. So where is the tooth belt with the stepper motor? Not, it's not, it cannot be seen, right?
Yeah.
Can be seen? Tak nampak kan? So I'm not sure what's the difference between left and right. It's looks like almost the same, but I would suggest that when you draw a diagram, draw one view like this. This is, I would say, front view. Another view is the side view. So when you draw a side view, you can actually draw the bed drive system. So you can see the bed drive is linked to the motor, stepper motor. Okay, so don't draw a duplicate like this, but draw one view is the, when you draw the engine drawing kan, you have the front view, top view, side view kan. At least when you draw the front view and side view. Okay, or if you think that it's going to help you, then draw the top view also. Okay, and level everything. So I would say that most of the labeling here is represented in the task 1, 2, and 3. Okay, that being discussed, so should be okay lah. Okay, and lastly is the task 5 is to explain the working principle. Okay, so basically, okay, working principle will be referring to this one, task 1. Okay, because you're explaining everything here, and then it's going to explain also related to this task 2 and task 3, the selection that you use. Okay, so based on all the tasks, and then task 4 also the diagram, I'm going to look at your working principle. Does it make sense? Make sense means that there's something that sometimes student, they copy paste from somewhere, and then they copy paste also working principle from somewhere, and up when they explain the working principle, it does not reflect to the diagram that they submitted. So which is totally wrong lah. So we know, the lecturer know that you didn't do it on your own, but you just copy paste and without understanding what's happening. So we are going to check all of the term that you are used in task 1 to 1, 2, 3, 4. Okay, and if everything is good, then makes sense to what you explain in the diagram, then you will get marks in this task 5. Okay, so I think I'm not going to share another assignment since it's already 8:56. But I hope that you guys get a view of what you should do to improve your assignment. Okay. Any question? Any question?
Ada.
Tak ada. Okay, if there's no question, then for tomorrow, let me just check. But can I just confirm, is my voice clear using this mic?
Yes.
Is it clear?
Clear, Josh.
Clear, Okay, if clear, then I think I can just continue my class using this mic. But I've tried to troubleshoot lah. I'm not sure why you cannot hear anything using my normal headphone. But anyway, that's all for today. And later I will open the feedback form maybe after 2 p.m. lah. Anything I will update in the Telegram group. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you, Ada.
Okay, bye. Assalamualaikum.